everybody, this is a video on equations of lines. Hopefully it is a refresher of what you learned last year in Algebra 1. A linear equation is an equation that forms a line when it is graphed. So I'll graph a line here. This line happens to have a positive slope, increasing from left to right. The point at which the graph crosses the x-axis, so this is the x-axis, this point right here would be called the x-intercept, and the point at which the line crosses the y-axis is called the y-intercept. The graph of a linear equation cannot have more than one x-intercept or one y-intercept unless it's the equation x equals 0 or y equals 0. So x equals 0 is this vertical line here, so technically you have like all these y-intercepts here. And y equals 0 is this horizontal line. So you technically have all these x-intercepts here. But in general, when you have a line that is either increasing or decreasing, so has a positive or negative slope, it will have one x-intercept and one y-intercept. In order to graph a line, you're going to need at least 2 points. Points on the graph are coordinates that make the equation true. So if we have an equation, let's say y equals 2x plus 1, the points on the graph of this line are x and y values that make that equation true. So for example, if x were to be 5, then y would be 11. The point 5, 11 would be on the graph when we graph this line. There's 3 forms of equations of lines. So first we have slope-intercept. That's the equation y equals mx plus b. The name of this form of a line is slope-intercept form because what you see from this equation is the slope and the y-intercept. So if we look at this example here, we have y equals negative 2/3 x plus 5. The slope is negative 2/3 and the y-intercept is 0, 5. So when you're graphing a line from slope-intercept form, you're first going to plot the y-intercept, and then you're going to rise and run according to slope. So in this case, because the slope is negative 2/3, we'd be going down to right 3, down to right 3, or up to left 3, up to left 3. Following that process is going to give you more than 2 points on the graph, but I typically like to plot more than 2 points only so that I can then connect them more easily without a ruler. The second form of an equation of a line is point-slope form. You may have seen it written like this first example, y minus y1 equals m times x minus x1. You might also see it written like this. That's just taking this minus y1 from the left and putting it on the right. That's something you'll see more with structures of equations in Algebra 2, so that's how we'll write it more in this course. Just like slope-intercept form, where it's telling you a slope and an intercept, point-slope form, just like the words say, is telling you a slope and a point on the line. So if we look at this example here, the slope is 2, and the point on the line is negative 5, negative 8. The x-coordinate of that point is always going to have the opposite sign of what's written in the parentheses. So if it's x plus 5, the x-coordinate is negative 5. If that were to say x minus 5, the x-coordinate would be positive 5. And then the y-coordinate, when it's written on this side of the equation, is always true to sign. So if it says minus 8, it's a negative 8. If it says plus 8, it's a positive 8. And so to graph the equation of a line from point-slope form, you're going to plot the given point, and then you're going to rise and run according to the slope. So in this case, the slope is 2. You'd go up to right 1, up to right 1, or down to left 1, down to left 1, and that will give you a bunch of points. The last form of an equation of a line is standard form. It's one that we typically don't see as often, but it's still important. In standard form, it's written ax plus by equals c, where a, b, and c are coefficients, or they have numerical values. What standard form tells you most easily without transforming it into slope-intercept form is the x-intercept and the y-intercept. So when you plug in 0 for y, we will have ax plus b times 0 is equal to c. Anything times 0 is 0, so ax is equal to c, and to solve for x, we get that x equals c over a. A similar process by plugging in 0 for x will tell us the y-intercept. So if we look at this equation here, 5x minus 2y equals 15. When we plug in 0 for y, we're essentially solving the equation 5x is equal to 15, so we get an x equals 3. And when we plug in 0 for x, we're essentially solving the equation negative 2y equals 15, so y is negative 15 over 2. To graph from standard form, plot the x-intercept, plot the y-intercept, and connect those 2 points. You would probably need a ruler to do that well. You can switch from standard form to slope-intercept form by solving for y, but that really is more work than we need to do when we can very easily, from standard form, just find the x-intercept and find the y-intercept and plot the two and then connect them. So a vertical line always has the equation x is equal to some number, because if you think about a vertical line, what is true about every point on this line? The x coordinate is the same. A horizontal line has the equation y equals some number, because when you graph a horizontal line, every point along this line has the same y coordinate. So those are a few things to keep in mind as far as vertical lines, horizontal lines, and the 3 forms of equations of lines. Now we're going to go through some examples. All right, let's do some examples. Before we get started, I'm just going to recap over here the 3 forms of the equations of lines. So that first one, y equals mx plus b, that's slope-intercept. The second one, y equals m parentheses x minus x1 plus y1, that is point slope. And the last one, ax plus by is equal to c, that is standard form. So when we are writing equations of lines, we are going to think about what we're given and then which form of the equation would be the best form to write it in. So when I'm given a slope and a y-intercept, it would make most sense to write the equation in slope-intercept form. So y equals mx plus b, y equals m is the slope, so that's negative 3x, and then plus b is the y-intercept, that is 5. Next example, slope is 0, y-intercept is negative 3. So again, slope-intercept form, y is equal to 0x minus 3. 0x is just 0, so this should be written as y equals negative 3, okay? So a line with a slope of 0, we discussed when we talked about slope, is a horizontal line, okay? A horizontal line always has y equals some number, whatever that y coordinate is. In this case, it's y equals negative 3. All right, in the next example, we've got slope and a point. So this point here is 5, negative 8. That's not the y-intercept, okay? A y-intercept always has an x coordinate of 0. So when I'm given a slope and a point that's not the y-intercept, I'm going to use point-slope form. So that is y equals m, which is slope, parentheses x minus 5, we're always opposite of the x coordinate, and then minus 8, we're always true to the sign on the y coordinate. All right, in this next equation, we want to write the equation of a line parallel to y equals negative 4, parentheses x minus 5 plus 2. So parallel lines have the same slope. So I know I want to be writing the equation of a line that has a slope of negative 4 because it's going to have the same slope as this equation. And then it's going to pass through the point 2, negative 6. So I know the point is 2, negative 6. So when I know a point and a slope, I'm going to write the equation in point-slope form. Y equals negative 4, parentheses x. We're always opposite of the x coordinate of the point. So if it's a positive 2, that becomes a negative 2 in the equation. And then the y coordinate is true to the sign. So if it's a negative 6 coordinate, it's a minus 6 in the equation. In our next example, we want to write the equation of a line perpendicular to this line here, y equals negative 2/3 x plus 4. So perpendicular lines have opposite reciprocal slopes. So what this is telling me that I'm going to be wanting to write the equation of a line that has a slope of -3/2 because it is the opposite reciprocal of this 2/3. And it's going to have the same y-intercept as this line. This line has a y-intercept of 0, -2. So when I know the slope and the y-intercept, I'm going to write the equation in slope-intercept form. In this next example, we're asked to write the equation of a line passing through the origin, that is the point 0, 0, and that has a slope of 1/2. Slope is 1/2. 0, 0 is just telling me that the y-intercept is 0, so that equation of that line, y equals 1/2 x plus 0, but we don't really need that plus 0, so I'll write it as y equals 1/2 x. In this example, I need to write the equation of a line parallel to the graph of 2x plus 3y equals 12 and passing through the point -4, 6. So 2x plus 3y is equal to 12 is written in standard form, and we can't see the slope of that line from the way that equation is written in standard form. So what we need to do is we need to solve for y to put this equation into slope-intercept form. So I'll start by subtracting 2x from both sides. That will give me 3y equals 12 minus 2x, and then I need to divide everything by 3. That tells me y equals 4 minus 2/3 x. So this equation here has a slope of -2/3. I need to write the equation of a line parallel to this equation. So that means I want to write an equation with a slope of -2/3 passing through that -4, 6 point. So when I know a point and a slope, I will write the equation in point-slope form. Y is equal to -2/3, parentheses x, always opposite of the sign, so plus 4, and then true to the y-coordinate, plus 6. In example 8, we want to write the equation of a line perpendicular to y equals 5x plus 3. So this line has a slope of 5, so a perpendicular line to that has an opposite reciprocal slope. That would be -1/5. And then it needs to have the same x-intercept of this line. So y equals 5x plus 3, and x-intercept you always get when y is equal to 0. Okay, so thinking about like an x-intercept on the graph, this point is always going to be some number, comma 0. Y is equal to 0. So we want to solve this equation for x. -3 is equal to 5x, divide by 5 on both sides, x is -3/5. So that's telling me that the point -3/5, comma 0 is on this graph, and I want to write the equation of a line through that point, -3/5, 0, with this slope -1/5. So when I have a point and a slope, that's not the y-intercept, it's the x-intercept. So I have a point and a slope, I'll write the equation in point-slope form. Y is equal to -1/5, parentheses x, always opposite of the sign, so that will be a plus 3/5 and then plus 0, but we don't really need that plus 0, so I'll rewrite it without that. All right, and the final example here has us writing the equation of a line given 2 points that that line passes through. So whenever we're given 2 points, we first need to find a slope. Okay, unless we're given the x and the y-intercept, and then we could kind of work backwards to write the equation in standard form. When we're given 2 points that aren't the x and y-intercept, we'd have to write it in one of the other forms, either point-slope or slope-intercept. In either of those forms, we need the slope in order to write the equation. So first I will find the slope of this line, change in y over change in x, and if you did that the opposite way using -6 minus 14 over 2 minus 8, you'll get the same thing. So 14 minus -6 is 20, over 8 minus 2 is 6, so the slope is 10/3. If you did that the other way, you would get -20 over -6, which reduces to -10 over -3, which is positive 10/3, because a negative divided by a negative is positive. So either way you set up the slope equation, if you do it correctly, you're going to get positive 10/3. So now we know a slope, and we know 2 points, but we only need one of those points to write the equation. We can use either one, it doesn't matter. So y equals slope of 10/3, parentheses x, we're always opposite of the x-coordinate, so -2, then that would be a -6, true to the y-coordinate. Or we could use the other point, y equals 10/3, parentheses x, opposite of the x-coordinate would be x minus 8, and then a plus 14 on the outside. All right, and the last thing we're going to do is some graphing. So when we look at the equation of this line, we've got y equals 2x minus 8. That is in slope-intercept form. Slope is 2. Y-intercept is 0, negative 8. So I'm first going to plot the y-intercept of negative 8. And a slope of 2 means up 2 over 1, up 2 over 1, up 2 over 1, or down to left 1. You can keep going in that direction, and then hopefully you have a ruler. You can draw in your line with a ruler or do your best to go through all of the points that you've plotted. This next equation is also in slope-intercept form. Slope of negative 2/3, y-intercept of 0, 5. So plot the point 0, 5. Negative 2/3 would be down to right 3, down to right 3, or up to left 3. And then we have a line that goes through those points. The last one is in standard form. So if you plug in 0 for x, you're going to get 7y equals negative 16. Y equals negative 16 over 7. So when x is 0, y is negative 16 over 7. That's the y-intercept. And then when we plug in 0 for y, we're going to get the x-intercept. For x is equal to negative 16. X is equal to negative 4. Negative 4, 0 is the x-intercept. So we'll plot that. Negative 16 over 7 is almost negative 2, 0, negative 2-ish. And we will plot that and then connect those two. All right, so that's it for equations of lines. Hopefully at this point you're able to take an equation of a line and identify key information about it. Which form is it in? What's the slope? What's the y-intercept? Or what's the point? Or from standard form, what's the x-intercept and what's the y-intercept? You also should be able to take verbal information and write the equation of a line like we did in the first 9 examples, and then also take the equation of a line and graph it. So go get some practice.